Visually solving equations. When you look at an equation like this, 2x minus 4 equals 6, you probably go through the process of 2x minus 4 equals 6, add 4 to both sides, cancels out, you get 2x equals 10, divide both sides by 2, and you get x equals 5. But what does it mean? Do undo. Okay, you devolve it into the times 2 minus 4 equals 6, and then you bring the 6 over and you add 4 to the 10 and divide it by 2 gives you 5, it equals 5. But what do the numbers mean? 2x minus 4 equals 2x minus 4. Subtract 2x from both sides and you get 0 minus 4 equals 0 minus 4. Or in other words, minus 4 equals minus 4. They'll tell you this is true for all numbers, but what does that mean, true for all numbers? 2x minus 4 equals 2x plus 5. Subtract the 2x's from both sides and you get minus 4 equals 5. Does a negative 4 equal 5? I think not. So it's false, no solution. But really, what does it mean? No solution. It all makes more sense when these equations are seen as line equations than a graph. Single variable equations are line or linear equations. They're often in the form of y-intercept equations. 2x minus 4 equals 6 is really two equations. Y equals 2x minus 4 and y equals 0x plus 6. Since they both equal y, they equal each other at one point. Y equals 2x minus 4 is an example of the general form, which is y equals mx plus b, where x is 0, y equals b because 0 times x, or x times any slope will cancel out. The point on the y-axis, 0b, where the line intersects it. The slope, m equals 2, is actually 2 over 1. For every one step in the plus direction, move 2 up in the plus y direction. Another example where the y-intercept is 0. Y equals x over 3. X over 3 should be thought of as the slope equal to 1 over 3. For 3 steps in the plus x direction, move 1 step in the plus y direction. Y equals minus x over 3. Minus x over 3 should be thought of as slope, m, is equal to negative 1 over 3. For 3 steps in the plus x direction, move 1 step in the minus y direction. Y equals 2/3 x. 2/3 x should be thought of as slope is equal to 2 over 3. Move 3 steps in the plus x direction and 2 steps in the plus y direction. Y equals 3x. 3x should be thought of as slope m is equal to 3 over 1. Move 1 step in the plus x direction and 3 steps in the plus y direction. Have a good handle on slope. Y equals 3 means the slope was 0 over 1. So y stays the same as x changes. You can keep moving 1 many times as you want, but you won't move up or down. Y equals infinity times x is not how a vertical line is done. For that, you'd set x is equal to 2, for example. It gives a vertical line true for all values of y at x equals 2. Yes, an x-axis intersect. Going back to the original equation, 2x minus 4 equals 6. The y-axis is where x is equal to 0. So the 2x is 0 and y equals a negative 4. So we make our point at negative 4. The right-hand side has a y-intercept at 6. So we'll make our green dot at 6. The number in front of the x is the slope or amount the line goes up or down for every step to the right. Y equals 0x plus 6 is the same as y equals 6, and the 0 means that y equals 6 no matter what x is. X comma b would be the series of points. For 2x, the 2 should be treated as 2 over 1, meaning that for every one step to the right, go up 2. The two lines intersect where x equals 5 at the point 5, 6. Test it out. 2 times 5 equals 10, minus 4 equals 6, and 6 equals 6. That x equals 5 and y equals 6 where the lines intersect is a mathematical truth. Proceed as normal and add 4 to both sides. 2x minus 4 equals 6. You add 4 to both sides, you get 2x is equal to 10. Now, y is equal to 2x and y is equal to 10. Notice that the solution after we graph them is still the same, x equals 5, because both lines have been shifted up by 4. Now divide both sides by 2. We get x is equal to 5. In other words, y is equal to x and y is equal to 5. The intersection is now at 5, 5, since the slope is 1 over 1, but x still equals 5. No change. Does this make more sense now? And wasn't the answer obvious graphically from the start? Now for another conclusion. This is slightly different. Let's start here. Multiply both sides by 3. Okay, 3 times 2x gives you 6x. 3 times negative 4 gives you negative 12. On the other side, 3 times x over 3 gives you x, and 3 times 1 gives you 3. Now we add 12 to both sides to cancel it out, and we get 6x is equal to x plus 15. Subtract x from both sides, we end up with 5x is equal to 15. Divide both sides by 5, we end up with x is equal to 3. Now we'll look at the graphics. 2x minus 4 is equal to x over 3 plus 1. Notice by graphing them at their intercept points, negative 4 for the red line and plus 1 for the green line, and then drawing the lines showing the right slope, 1 to the right and up 2 for the red line, and 3 to the right and up 1 for the green line, they intersect at 3, 2. So it's pretty obvious x equals 3. We can even test it out. 2 times 3 is going to equal 6. Subtract 4 from it, it'll equal 2. On the other side, 3 divided by 3 is 1, plus 1 is 2. So 2 is equal to 2, which is to say y equals 2 for both lines at x equals 3. After multiplying each term by 3, we end up with 6x minus 12 is equal to x plus 3. Again, go ahead and graph them. Use the y-intercepts, and then graph the slopes, and we still end up with the answer x is equal to 3. Skip a few steps because the graph doesn't go up to 15. Well, you finally end up with x is equal to 3. As you can see, y is equal to x is just a 45-degree line going up, and y is equal to 3 is just a horizontal line going to a 3. It still intersects at 3 because we did the same operations in each. Okay, true for all numbers. 2x minus 4 is equal to negative quantity x plus 6 plus 3x plus 2. Okay, we distribute the negative sign. We end up with negative x, negative 6, plus 3x, plus 2 on the right side. We add all the common terms together. We end up with 2x minus 4. We have 2x minus 4 on both sides. Well, we can go ahead and add 4 to both sides and end up with 2x equals 2x. We divide out the x on both sides and get 2 equal to 2. We can get x is equal to x. So true for all numbers. What's it really mean? Okay, we skipped a few steps again because the graph didn't go to 15, but 2x minus 4. Both lines intercept at minus 4. Both lines have the same slope. So it must be true for all numbers. Whatever value we use for x, we're going to get the same value for the other side because it is the same line. Red plus green equals yellow. I made it brown to show up, so I added 2 colors together. Skipped a few more steps because the graph doesn't go to 15. We end up subtracting 2x from both sides, and we end up with negative 4 equals negative 4. Y equals negative 4 superimposes both lines again because they're identical. They are the same line. Or we can do it like this. X is equal to x. So y is equal to x for both sides. We could divide both sides by x. So we get 0 is equal to 0. So both become y equals to 0, which is also true for any value of x because they are the same line. Now a different one. 2x minus 4. And we go through and we distribute the negative sign and we add up the common terms. We get 2x minus 4 is equal to 2x plus 5. We subtract 2x from both sides, or divide 2x from both sides. We're going to subtract it. We get negative 4 is equal to plus 5. That's false. There's no solution. What does it mean? Okay, look at it. 2x minus 4 equals 2x plus 5. The one line on the left-hand side, it intercepts at negative 4. The other intercepts at plus 5. They both have the same slope, going one right and two up. So they're going to remain parallel. They will never cross each other. So there is actually no solution to it. That's what's meant by there's no solution. Lines are parallel. Even if we go ahead, subtract 2x from both sides, we get minus 4 is equal to 5. That's going to be y is equal to minus 4, y is equal to 5. Still, if we divide it out, no matter what we do to it, up with two parallel lines, certain distance. Okay, for any line y equals mx plus b1, b1 being a specific number for the y-intercept, there's an infinity of y equals mx plus b anything. Any other point, any other y-intercept except that particular one. And only one identity parallel line, that being itself, y equals mx plus b1. Of course, there are an infinite number of points on a line that it has in common with itself. Though one parallel line passes through each point, which I've drawn as yellow, there are an infinite number passing through the same point that are not parallel and intersect the original red line at one point. Okay, in summary, we're looking at 2/3 x minus 1 equals 1. We could do it the do-undo way, where we take x has been multiplied by 2/3, so over on the right-hand side we reverse it, and multiplying by 3/2 is the same as the division. We subtract 1 from it, so on the right-hand side, the undo, we put a plus 1, and it equals 1. So we take our equals 1, move it over to the right-hand side, we get 1 plus 1 is going to be 2, and 2 times 3 over 2 cancels out the 2's, and we end up with equals 3. Or we can do it the other way. 2x minus 3 equals 3 after multiplying each term by 3, and 2x equals 6 after adding 3 to both sides. Dividing both sides by 2 yields x is equal to 3. However, if we just look at our graph, if we just graphed our numbers, we look up there and see the intersection is where x equals 3 and y equals 1. And what we discovered, however you do it, the graph gives a visual meaning to the numbers and a third way to find an answer. I hope this is as helpful for you as it was for me to make it. Have a good day.